You have filled out almost the entire chart there, right? I believe that the only thing that we are missing now is that very last row. Is that correct? Okay. So I want to make sure that we have this one filled in because this is an important piece. This is something that if we had lots of time or if the content moved a little bit deeper, we would spend a lot of time with this. But I want to spend just a little bit of time making sure that you understand this idea that goes with the gravitational and the electric field. So I think we're all okay with the idea that a frog, if he's sitting right here and is let go, what's going to happen? He's going to fall, right? He's going to fall because he's in a gravitational field. It looks like this, right? It looks like the flat Earth just because we're looking at the micro scale. So now the next question that I'm going to ask is, if I have the frog right here and I lift him to here, what am I doing? Don't overthink it. We've talked about this before. It was a number of weeks ago, though. What was it? I'm doing work. Does that sound familiar to you? Yep. If I move the frog from down low to up high, I am doing work. So if we put that in a little bit more broad terms, we can say that if we move the object let me ask you, am I moving the object in the direction of the gravitational field or opposite the gravitational field? Opposite the gravitational field. If I move an object in an opposite direction, of the arrows of the field, what did you just tell me I'm doing?
Work.
Indeed. I apply a force over a distance, which means that I'm doing work. And in doing work, I'm changing the gravitational potential energy of the frog. So again, I'm moving the object in the opposite direction of the arrows of the electric field. I do that by applying a force over a distance. That means I'm doing work and I'm changing the gravitational potential energy. Remember, gravitational potential energy is mgh. Do you remember that? I'm not going to ask you to do that calculation, but I do want you to understand that if he's here and then I lift him up to here, I've increased his gravitational potential energy. And really what I've done is that I've moved him in the gravitational field opposite the way that he would normally go. Question?
You do less work as you do less work. You do increasing the distance.
So are you saying because my R is getting bigger? Is that what you mean? So yes, technically. So let me make sure that everybody understood what his question was. Ethan said, so if I move him, as I move him up, am I doing less work because I am counteracting a smaller force? Yes, technically, but if we think about the size that the Earth is, right, the radius of the Earth relative to how much I'm moving him, the amount that I'm moving him is very, very, very small, right? Very, very small, because this is really my G. The GM over R squared is really my little g, my acceleration, and that's not changing a lot. I would have to have very, very precise measurement tools to get that. This is a good question, yeah. Yeah. Hey, do I do work if I take the frog like this and I move him like this? Like, do I do work? No. So that's just another little mental note. If you move an object perpendicular to the field lines, no work is done. That's interesting. Write that down. If an object is moved perpendicular to the field lines, no work is done. Interesting. Let's take a look at what would happen to a charged particle. Let's take a look at what would happen for electricity. Same kind of story. If I take a positive charge, so I've got a positive test charge, I'm going to put it right here next to this positive charge, and I want to move it this way. In order to, I'm sorry, I take that back. I'm going to put it over here, and I'm going to move it in. If I want to move it in, does it want to go in? Does a positive test charge want to get closer to this charge? It does not want to. So in order to do that, I'm going to have to push, aren't I? I'm going to have to apply a force over a distance, which means that I have to do what? Hey, it's a beautiful thing here, friends. It's the same deal. If I move a charged object in the opposite direction, of the arrows of an electric field, in order to do that, I have to apply a force over a distance, which means that I'm doing work. Which means that I am changing what? Well, in this one, the one right next to it, the one on the left, I'm applying force over distance doing work, and that's changing. What was this thing? P sub G, what does that mean? Gravitational potential energy, right? MGH? Yeah. So let's try and do some parallel thinking here. Move a charged object in the opposite direction of the arrows of an electric field. I'm going to apply a force over a distance. I'm doing work that's going to change. Not kinetic. It's still potential. Is it gravitational potential?
No.
What kind of potential do you think it might be? Electric potential, yeah. Yeah. There you go. We're going to use this in a couple days too, but I just wanted to share that with you now and have it written down. Okay? Is that okay? The parallel thinking here is what we really like. Parallel thinking is the deal. All right. Today, we're going to do magnetic field, or we're going to do magnets. Okay? I will tell you that sometimes the first time I introduced this in a class, we were like, oh, I did this when I was in preschool. I did this when I was in third grade. I know this stuff. Yes, you do. You know a lot of it, but we're going to go a little deeper than you may have otherwise seen. Okay? So I'm going to just show you really quickly here. Boop. On this sheet, there are 4 explorations that you're going to do, but I don't want you to just do all the explorations in a row. I want you to do an exploration, then do a little processing, and then do an exploration, then do some processing. So exploration 1, and then you're going to write down some things. Now, these things may be things that you already know, maybe things that you're kind of familiar with, or they may be things that you need to look up. There are textbooks in the back. It's all there, okay? Section 19.1, so chapter 19, section 1. So do exploration, do some stuff. Exploration, write down some stuff. A couple more explorations, a little more stuff. Does that make sense? I want you to do the stuff in between the explorations as you go. Okay? So we're going to do it kind of a little bit at a time. If you have questions, obviously, you're going to ask, and that will be just fine. I'm going to take you back to the back to kind of show you where everything's at, and then we can get started. Sound good? Okay.